Hello everyone. Today let us see how to convert between various number systems. Most popular number systems that we use are decimal, hexadecimal, octal, ternary number system, binary number system, and many more number systems that we do not know the names of, but we use these as the most frequent number systems. What exactly is a number system and what does it have? A number system is a way of how you represent a value. For example, we have decimal number system in that we have some digits with which we represent any value. The digits that we use in decimal number system are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. In hexadecimal we use 0, 1, 2 and so on to 9, and then we use A, B, C, D, E and F. So F actually represents 15, and in octal number system it is only 8. Octal is 8. So it means that the maximum number of digits that which we have in this number system is only 8. So if we are starting the number system with 0, then the maximum we can go up to is 8 minus 1, that is 7. So it is 0, 1, 2, 3, 4, 5, 6, 7. So these are the only things that we have in octal number system. These are the only ones we have in decimal, hexadecimal, and these are the numbers we have in decimal. Now let us go into more detail. What does a number system do and what does it have? So there is a base for every number system. Every number system has a base or a radix. What is a base or a radix? A base or a radix for a number system indicates the number of digits that which are used in that number system. For example, if we want to represent a decimal number, we can write like this: 21 to the base 10. Here 21 is the value and 10 is the base or the radix. What exactly do we why exactly do we need the base or the radix? We just want to know what is the number or what is the number of digits that we are using in that number system. If we do not have a base or radix, the same value 21 will have a different digit representation, hexadecimal, different digit representation in octal, in ternary and in binary. So if we are representing something like 81 and we write base 8, so basically we are meaning that it is base 8, so it is an octal number system. The number of digits that which we are using in that octal number system is only 8 digits. So 0, 1, 2, 3, 4, 5, 6, 7 are the digits that which we are using in octal number system. So this is a wrong value actually. We should not see 8 when we are using octal number system. Similarly, if we are using something like 789 to the base 7, I write 7. So there are only 7 digits: 0, 1, 2, 3, 4, 5 and 6. So this is a wrong representation of the number system. Either the value representation is wrong or the radix is wrong. So this is how you should basically be able to figure out what exactly is a correct number representation and what exactly is not. Similarly, let us now see how we convert between different number systems. We will follow a simple procedure in which we will first convert the number to a simple equivalent decimal form, and from that decimal form we will convert to the next number system. Why are we using to convert to decimal representation every time? Is by default the numbers or the tables that which we have been using from a long time are based on decimal. All these are used in further mathematical calculations that which we generally do not frequently use. So it will be very convenient for us to convert in this form. I'll show you an example. If we have to convert, say, let me take 521. We are converting 521 from this base 7. We want to convert to an equivalent value representation to base 8. Okay, so how are we doing? Before conversion, we should know what is the place value for each and every digit in that number system. What is a place value? This is 0th place, this is 1's, this is 2's. So each and every place has a number. And what is the place value? If we have 7 and the place is 0, then the place value is 7 power 0. That is exponential equivalent of that base representation of the number system. If 521 is there, then this is 7 power 0, this is 7 power 1, and this is 7 power 2. How do we represent the equivalent value in all the 521 of this base? So 7 square is 49, or let's write like this in first, plus 2 into 7 to the power of 1 plus 1 into 7 to the power of 0. So it is 49. 5 into 49 plus 2 into 7 plus 1 into 7 to the power of 0 is 1. So 5 into 49 is, it is 245 plus 14 plus 1, that is equal to 260 on a total. So this is the equivalent value representation of this number system in the base 7. This is the equivalent representation of which number system? We have followed decimal based calculation, so this becomes 260 to the base 10. Right? Any number system, if we expand it in the form of place values and we multiply the place values with the corresponding digits and we add them all, we are doing all additions, all multiplications and everything in decimal, so we are getting a decimal equivalent. Now we will convert the decimal equivalent 260 to the base 10 into something equivalent to the base 8. Very simple. 260, we have to divide it and write the reminders out. So so it is 24, right? So it is 8 3s is 24. We get 20 as a reminder. 8 2s are 16. Then we get reminder 4. And next 8 4s are 32. Reminder is 0. So we write the equivalent number system in this order. First this one, next this one, and so it is 404 to the base 8. And that is the value, 404 to the base 8. This is also 404 to the base 8. 521 in base 7 is equal to 404 to the base 8. We will get a good correlation from these two numbers. As we are using more and more digits to represent a value, the ultimate number that which we see will be smaller. The same thing if I represent it in hexadecimal, it will be even more smaller. The same thing if I represent it in something more than hexadecimal. Hexadecimal is base 16. If I am representing in base 20 or in base 25, even the value that we are seeing will be smaller, but the base will be bigger. The value, I exactly do not mean the total value. The number representation we will see generally, if we ignore the bases, right? We generally see 521 is greater than 404. Agreed? When I'm showing you the bases, then you will be puzzled as which number is greater. So 521, is it greater, or 404 to the base 8 is it greater? So if at all you ever get to a situation like which value is greater, then you just expand that number system. So you just write 2, 1, 0 the places and then derive the place values for it. How do you derive place value from places? You just make that base multiply these many number of times. So 7 multiplied 2 times, 7 into 7, or you can write directly 7 to the power of 2, 7 to the power of 1, 7 to the power of 0, and then you get 5 into 7 square, and then you write the equivalent value. Similarly, you derive the equivalent value for this number also, 0, 1 and 2. Then it is 8 square into 4 plus 8 power 1 into 0 plus 8 power 0 into 4. You get equivalent value. Then after you get equivalent value, you decide which number is greater, right? So, and if you are converting something from one base to the other, make sure that you first derive the value, and then after you get the value, you just need to divide this value in this manner, and after that this goes first, this goes first, and or if you are writing in this manner, then it is in the reverse order. We will just to cross verify if this number derivation is proper or not, we will again try to derive the equivalent base 7 from 404. 404 to the base 8, we will see how much is this equivalent in base 7. Okay, so this is place 0, this is place 1, and this is place 2. That means it is 4 into 8 square plus 0 into 8 power 1 plus 4 into 8 to the power of 0. Now it is 4 into 64 plus 0 into anything is 0 plus 4 into 8 power 0 is 1 plus 4 into 1 it is 4. 4 into 64 is 256 plus 4, that is 260. Alright, this is in the base 10. Now let us now divide how much into which base we want to convert. We want to convert into base 7, so we have to derive the equivalent and divide the equivalent with base 7. So it is 7 3s are 21, we get 50, 7 7s are 49, remainder is 1, and again 7 5s are 35, remainder is 2. Now it is 5 2 1, and this is to the base 7. 5 2 1. See, both are equal. 521 to the base 7 is 404 to the base 8. Similarly, when we derive, it is the same. And the most general or the most frequent thing that we will see is this one, decimal to binary or something like that. Let us take a different example. I wanted to derive this into binary. Then what do I do? Binary number system has how many digits in it? Only 2 digits, 0 and 1. So what is the base? How many digits? 2 digits. Base is 2. This is the base. Now with which number do we have to divide? With 2. So now it is 121, remainder 1, 60, remainder 1, 30, remainder 0, 215s, remainder 0, 217s, remainder 1, 23s, remainder 1. Now write this in this order: 1 1 1 1 0 0 1 1, and don't forget to write the base value. So it is 243 to the base 10 equal to this number. As simple as that. If anyone asks you to derive, for example, the previous example that we did, if we are having 404 to the base 8 and someone asks to derive an equivalent binary, very simple again. Anything you have to convert into decimal first. Just because in the previous example this was in decimal, we have converted into decimal. we have converted into directly binary. Okay, because this is into a different base representation, we have to convert to an equivalent base 10 and then divide. Alright, so it is 0, 1, 2. 8 square into 4 plus 8 to the power of 1 into 0 plus 8 to the power of 0 into 4. 64 into 4, 256 plus 4, it is 260. This is in the base 10. Now 260 we are converting into binary, so divided with 2. 2 1s are 2 3s are 0, remainder 0. 2 6 are 12 and 10, it is 5 0. 2 3s are 2 2s are remainder 1. 2 16s are remainder 0. 2 8s remainder 0. 2 4s remainder 0. 2 2s remainder 0. 2 1s remainder 0. So the equivalent number is like this: 1 0 0 0 0 0 1 0 0 to the base 2. So 404 to the base 8 is equivalent to this number in binary. So this is how, folks, you convert from one number system to the another. There are many other ways, but this is a very simple way that which I have found. Perhaps this procedure might be a bit tedious, but gives you a very simple way to resolve things. Thanks for watching, and find this video and the scanned copy of this notes in damnhit.com for your further reference. Have a good day.